Now let's look at existence of antimatter, or what you can call antiparticle. So yeah, I can say that the antiparticle of a charged particle will have same mass but opposite charge. So the antimatter of a charged particle will have the same mass with that particle but opposite what charge. Examples. So examples. You can talk about particle and the antiparticle. Particle and the antiparticle. You have electron, which is called the negatron. Negatron. It has a charge of -1, nucleon number of 0. The antiparticle is a positron. Nucleon number is 0, proton number is +1. Up quark, the charge is +2/3e. You have the anti-up quark. Symbol is U with a bar. The charge is -2/3e. Down quark, the charge is D. The symbol is D. It has a charge of -1/3e. Then you have the what? Anti-down quark. The charge is +1/3e. You can go on and on like that. 3, 4. You have neutrinos, or what you can call the electron neutrinos. Nucleon number 0, proton numbers 0. Then you have the anti-neutrinos. That is this with a bar, 0, 0. These are some examples of particles and the antimatter. What this basically means is that every particle has its antimatter. So the antimatter of a charged particle will have the same charge but opposite what? Opposite. It will have the same, the antimatter of a charged particle will have the same mass but opposite charge. Now, annihilation or annihilation. Annihilation is a process whereby matter combines with its antimatter, with its antiparticle, to disappear and produce energy. So basically, I can say that annihilation is a process. So annihilation is a process whereby a particle combines with its antimatter, its antiparticle, to disappear to produce what? Energy. So annihilation is a process in which particle, e.g. an electron, combines with its antiparticle, e.g. a positron, and disappears to produce energy. So for example here, if a negatron is 0 minus 1, combines with a positron, 0 plus 1, it disappears and exists in form of 2 gamma photons. This is a process known as annihilation. So this is a negatron combining with a positron. It becomes annihilated to produce 2 gamma photons. Okay? So, very quickly, let's talk about the decay of a proton. A proton, proton 1, 1, it has a nucleon number 1, proton number 1. It disintegrates to produce a neutron, 1, 0, in the nucleus. All these are occurring in the nucleus. And in order to balance this, you will need a positron, so that you balance the nucleon number. 1 plus 0 is 1, 0 plus 1 is 1. And whenever a positron is produced, a neutrino is also produced. So, a positron, which is a beta plus, which you can write to be what? Beta plus particle, is produced in the nucleus when a proton decays to form a neutron. So you don't have beta plus particle in the nucleus. What you have in the nucleus are protons and neutrons. But when the proton decays to form a neutron, a beta plus particle is produced. So I can write it in terms of quark composition. Proton is up, up, down. It decays into a neutron, up, down, down. Then produces a positron, beta plus, and a neutrino. So we can easily say that a positron is produced when an up quark disintegrates to a what? A down quark. When an up quark disintegrates into what? A down quark. So in order to balance the charge, this will be plus 2 over 3 changing to minus 1 over 3 plus 1. Because the charge of this up quark is plus 2 over 3e. It changes to a down quark having a charge of minus 1 over 3e. To balance it, I have to add plus e to it. So plus 1 over 3e plus e will give you plus 2 over 3e. So this actually produces what? Plus 2 over what? 3e, which is what actually balances that change. So based on charge conservation, when a proton decays to a neutron, a positron must be what? Must be produced, or beta plus. Then decay of a neutron. When you have a neutron, neutron 1, 0 decays to proton 1, 1 plus a negatron with an antineutrino. The same thing applies here. This actually up, down, down to give you up, up, down plus a beta minus particle and an antineutrino, neutrino with a bar. And this because one of the down quark having a charge of minus 1 over 3 has changed to an up quark having a charge of plus 2 over 3. To balance that, a beta minus will be produced. So when you add this to this, you are going to have plus 2 over 3 minus 1 over 3 minus e will give you minus 1 over 3e. So based on the conservation of charge, when a down quark changes to an up quark during the decay of a neutron to a proton, beta minus is produced. Okay.